password for the currently logged in user. However, run it with help and you'll see how you can add a new user to the database. So SMB password with the A option, followed by the user's name, student1. Now it prompts us, we'll set it to ABC123. And now when we cat the contents of SMB password, you'll see 3 users. And also, coincidentally, student1 has the ID 501. Let's grep again student1 from etc password just to confirm that, and there you see the user has 501. So the mappings are done purposefully. Now with that all said, we need to start the Samba server and attempt to connect. It doesn't make sense to go through all these directives to not be able to use the service. So through status or from the shell, you can attempt to start the server. Go ahead and click Start All, and this will attempt to fire up all of the services. And we'll see how it returns. If it's successful, then we'll confirm either way, pass or fail. Now it appears to be running. From the shell, let's confirm. Service, and again, the service is located in etc. All the services are initd, and it's SMB. When you start the SMB service, it automatically starts the NMBD service. So it's PSEF grep SMB, and it starts multiple instances. And let's grep NMB. It's also running. So by starting the Samba instance, it'll cause NMBD to be started. And also WinBind is running, although it's not currently configured. So Samba is up and running, which means we can attempt to connect. And if we were to use SMB tree to try to enumerate the contents of the network, we will see Linux CBT Serve 1. There it is. It has an IPC, or Inter-Process Communication share, which is a default share published by Samba servers, including Windows. It doesn't show the home share, but when you connect, it'll publish the home share. So Serve 1 is up on the network. From a Windows perspective, we should be able to interact with it. Now, we do have a Windows box available on the network that we could test. But to connect to it, we'll need the RDesktop utility, which is on our, or in our repository on the Apache server. So let's search for RDesktop. There it is. And it's 141. So from the shell, we'll just use yum install. And this will install RDesktop momentarily. And in our notes, we'll just note, or task 2, install RDesktop and connect to Windows XP to test connectivity to Samba. So to do so, we simply execute yum-y install RDesktop, which fetches it from our repository. Let's confirm at the shell what's going on to see if it's successful, and as you can see, it has completed, which means it's installed. And RPM query lists of our desktop will reveal what's going on momentarily. And if we scroll through, we'll see that there are many files, but the key file is in user bin, which is accessible to all users. Documentation is included, a man page is included so that you can see how to use RDesktop, and it has support for multiple languages. If you execute RDesktop with no options, it dumps the usable options. The newer versions of RDesktop supports all sorts of redirection features such as COM port, LPT ports, parallel ports, floppy ports. Redirections that are not so critical nowadays, but nonetheless still work. Now, when connecting to a remote system, it's important that you indicate the resolution of the screen, or F for full screen, the bit depth to control how many colors are returned to the screen, and that's usually using the A option, as well as the host name. So we're going to execute RDesktop -F-A, let's set it to 16 bits, space the server's IP address, and optionally the port. Now we've got a system on the network that is, we'll use SMB tree again, that is running XP, and it is named Linux CBT Win2, a system that we attempted to connect to with one of the SMB clients, perhaps even SMB client itself. Let's connect to this system. using our desktop full screen A16 for 16 bits or 65,536 colors, and the IP address of the remote system, which is 75.176. You can confirm it, of course, by attempting to ping the host. This will pull up a full screen momentarily for Windows XP on our desktop. The user in which you are logged in as on your Linux box will be supplied, as is the case here. We may then log in as a user. Let's see if we have credentials as this user. And it doesn't allow us, so we'll try to log in as administrator, which we certainly have access to log in as. And momentarily we'll have an administrative desktop. So here's our desktop. It contains different programs from previous studies, and we will attempt to look at the network using My Network Places. We'll maximize this. We'll wait for it to refresh. It's taking a little while. Sometimes F5 will do the trick. And nothing, so we'll try again. Sometimes the refresh takes just a little bit. We'll try View Workgroup Computers. There we see the computers. Let's view details. So we've got Serve 1, Win 1, Win 2. These two systems are Windows systems. Win 2 is what we're currently connected to. The Serve 1 box is a Samba system. Now notice when we double click, it prompts us. It asks us, who are we? We need to tell it who we are. We're going to say that we're the user root with the password ABC123 connecting to the system. And now you see root's home directory published, just like that, with printers and faxes, albeit they're none defined. So now we can connect to root's directory. This is root's home directory, and copy items from the server to our local system. So let's go ahead and copy something to our local system that's of a reasonable size. Here's something that's 10 megabytes roughly, a test file. And we'll copy and paste it to the desktop. This will copy it from the remote system at LAN speeds. And we can also rename it, copy it back. We now have full read-write access to root's directory, and if we open a PuTTY session to the server, we'd see the file that we've returned with the appropriate permissions. Let's find the PuTTY instance and connect to the server located at 75.10. We'll log in as root. And in LSLTR we will find the file. Let's check the directory. And we should see test return towards the top. There's a copy returned. And it was not updated. We didn't make any modifications. We simply renamed the file, which preserved the original timestamp information. And as you can see, Samba wrote the permissions as 744, which can be adjusted for the home share with respect to what items are written as. But nonetheless, we've authenticated to the remote system using user base authentication. Let's log off for now or disconnect. We'll reconnect momentarily. User base works exactly as we've mentioned. So long as you use SMB password or the interface, the SWAT interface, to update the SMB password file, you'll be able to authenticate as these users. But the maintenance of this file can be what can get out of hand as your user base grows, which is why you may want to consider Active Directory authentication and integration to centralize or keep your users centralized, because password management of this can become a nightmare. We have 3 users, and if they decide to change their passwords, it all has to be updated in 2 places. One perhaps in Active Directory, and the other place being the Samba password file. So user base works as follows. If you set it to server with a password server to authenticate against a remote server, it will work similarly, but you'll still need a mapping in your SMB password file to point the Samba user or NetBIOS user to the local Linux user. So that's user base setup. Now what we want to focus on next is Active Directory base setup.